Hey, it's William VE4VR here. Just going to give you an update on some projects I've been working on over the past 6 months. So I guess the first one, the Sierra Radio Systems ham stack. This is a repeater controller system that we use here in Winnipeg and some of our linked repeaters. So this particular setup that I have right here, it's got a controller board on the bottom and 3 radio boards. So those radio boards can be connected to repeaters or links. So that's a nice little expandable controller. But we happen to get this Comm server board. So what the Comm server board does is include a BeagleBone Black and a I2C audio codec. But the software for this wasn't quite ready for what we wanted to do, so I ended up spending a day on it. And I built All-Star Linux or ASL on the latest and greatest BeagleBone image. And then I was poking around doing some voice control stuff, because if you have this board out in the middle of nowhere at a repeater site, then you could talk to it and say, hey, bring up the link to wherever, and it can send the serial commands back to the controller through the backplane, and you can actually have it bring up and down links with voice even when there's no internet. So that's kind of a neat thing. The All-Star side of it, I had it running for about a month, just plugged in at home testing, and it's nice and stable. So that was an improvement. I'll have to actually work on building a fresh image for that and maybe posting that. What else? Someone on Facebook, visually impaired ham, was talking about which radios were the easiest to control if you couldn't see them. And I thought about the work I was doing with voice control and thought I could probably do something without having to buy any special radios. So I did. So here's a $20 aftermarket ICOM CIV cable, and I picked that up off eBay. So this is just USB serial going to the ICOM CIV. Then if you have a Raspberry Pi, you can get HamLib. So HamLib includes rig control and rot control, so radio and rotator control. And then if you have the USB audio, now you can say, hey radio, go to 14652. And all it has to do is understand, hey radio, go to 14652, and translate that to the shell commands to say, hey HamLib, tell the radio, go to 14652. And you've given basically, I don't know, 100 different models of radios voice control. So you could also do the same with your rotator. You could say, hey rotator, go northwest, and it'll point over there and come back. Or you can ask it, what's the radio doing? This thing will talk through HamLib to the radio and get the current frequency and RSSI and all sorts of good stuff. So that's a cool little project that I don't know if anyone's done anything like that already, but this is totally worth spending some time on again. So I want to build this out. I can still see okay, obviously, and I think this would be useful in the car if you're driving around, being able to say, hey radio, go to the local repeater, and have it just go ahead and do that. And you don't need internet for that either. It's really simple voice commands. What else has been going on? Picked up some of these Tate radios off eBay. And these are new old stock commercial radios that were available. It had a modem inside. So open them up, disconnect the modem, get them all ready to go. They're software defined, and they do 5 watts at continuous duty, or 12 and 25 watts with a different duty cycle. And then you can program the 15-pin connector on the back as GPIO. So you can have PTT, COS, PLD code, or whatever you want. And they're SDR. They just transmit beautiful, clean signals. So the first thing I did is always wire up an IRLP interface. So here's everyone's favorite USB fob that's really popular in the All-Star Linux world. And then just made up a cable for IRLP to this, because that's easy enough. I also did do an All-Star cable for it, and it works fine because you don't even need any transistors. You can just wire it right to the GPIO. So that was a neat setup. And they actually work so good that the D-Star and Fusion radios came back digital even through the IRLP echo reflector, so they're nice and clean. Then next, I've been working on Northwest Digital Radio stuff. So this is a kid's computer kit. It's called the Kino Computing Kit. So this is something I came across in December when I was out looking for things for my kids. So it comes with a wireless keyboard, and it's got a 10-inch LCD screen here. So you got the LCD screen, and it's basically a Raspberry Pi kit for kids, so you can learn how to do Minecraft and stuff like that. But I'm a big kid, so I installed the Northwest Digital Radio draws board onto this kid's computer kit. And then I have the Ambi 3000 transcoding stick. So this little portable setup can actually talk pretty much to every different digital mode. And I'm also doing stuff like the Google, that kind of voice integration. So I just made up a cable that goes from the 6-pin to one of these Tate radios. And then I haven't done anything with the GPS yet, but I'm thinking when I get into doing some high-speed data, it might be useful to be able to synchronize multiple sites together using GPS, just like in the commercial wireless ISP world or cell site world. So This was the original Northwest Digital Radio UDRC board, and this red board we had in use at the university at our repeater, and we were actually running D-Star on a Fusion repeater, and it worked great. So I borrowed this because I was really eager to play with this, and it hadn't arrived yet. So I tried my first test on the UDRC, and then the second stuff I started working on the DRAWS board. DRAWS is a little bit newer, so this is the Digital Radio Amateur Radio Workstation. Has a GPS on board and a couple radio ports, battery backed, and then that USB stick combined with all this stuff. Basically, you can talk to any different digital mode if you're willing to spend the time and write the software. And there is even an MMDVM project that's been compiled for this. So I was poking around with MMDVM running in software mode and connected up to these radios. But I will have to post another video because this one's getting pretty long already. And I'm going to get into specifically just projects with this board, because I love this kid's computer kit. Like, this actually is really cool. There's a touchscreen version of it that I might track down yet, because this would make a really nice digital station control where you can go tap on the screen and select different bands and frequencies and modes. And if you have this with that digital hardware, and I use something like the ICOM CIV cable here, you could tell the radio, go to a certain frequency, and then basically you can talk to every known form of communication with that piece of hardware. So this is a cool setup, but that's it for the quick tour of the things that I've been doing. As I said, I'll do another video specifically on the DRAWS hardware and software next, but that's it for now. 7-3.